Welcome to Daily LeetCode, Daily LeetCode, LeetCode, Daily LeetCode, day 53. We are back once again. We have a short timer today as well. Doing a lot of prep not prep, just doing problems. Doing a lot of problems the last few weeks. So that being said, I guess you could say I'm preparing. I'm preparing for the game of life, the war of life. But yeah, I've been doing a lot of problems the last 2 weeks or so, last 3 weeks or so. And yeah, sometimes you gotta walk so you can run. So I think we're gonna be doing some recovery problems basically. What that basically means is shorter sessions, I think mostly focused on review, maybe for like just this next few days. So definitely need to recover. And then I think maybe starting on Monday or Tuesday, then we'll be back to regular length grinding. But you know how it be. Gotta walk so you can run. But day 53, day 1 to day 53 came and went. So we are back once again. We got a dope suggestion from our boy, Thomas Wong, the legend, the GOAT, the inventor of the modern computer, the man, the myth, the legend. He said, here's a little hint on 1763. Sliding window does work and it could get to optimal. Try combine a little bit of brute force with it. The hard part with sliding window. See, he has a good point. He has amazing point here because I was just thinking about this. I remember thinking about this problem earlier today earlier yesterday, and I was like, dang, when do we reset? That's kind of the thing with sliding windows. So coming up with the condition for when to intake and when to shrink the window. So gonna give it another shot. So let's give this one another shot today. It's an easy, I think our solution was n cubed time because we're iterating through the string. For each string, we're going to iterate from that indice towards the end, which basically is n squared in the worst case. And then isNice is a function that determines if a string is nice. And this runs in linear time worst case as well, since we're iterating over the string that's passed in, but the string worst case could be the length of the array. So our current approach is n cubed, and we'd like to do better than that. I think our space as well, our space maybe could be worst case O of n space in the case that we use isNice, right, in the set, right, for every character in the set. No, maybe not, because the set would have up to, if it's upper and lowercase letters, right, that's 52 total keys, so it'll be constant set size. But we are pushing them all into this nice strings array, and I guess it's possible that the whole string is a nice string, or each pair of strings is a nice string. So I guess in the end, all nice strings, which is part of the output that we use, I guess it would still be linear space then. So we want something better than that. So let's think about that. So a string, I didn't even set the timer, but basically it's 5:10, 5:13. We're going to do 30 minutes. A string S is nice if for every letter of the alphabet that S contains, it appears both in uppercase and lowercase. String S is nice for every letter of the alphabet that S contains. It contains 2 letters of the alphabet. It appears both in uppercase and lowercase. For example, AB and ABB is nice because A and A appear and B and B appear. Right, so we have uppercase A and lowercase B and uppercase B, but it's okay to have something beyond that once you have that case. However, ABA is not because we're missing uppercase B. Given a string S, return the longest substring. Given a string S, return the longest substring of S that is nice. Given a string S, return the longest substring of S that is nice. If there are multiple, return the substring of the earliest occurrence. If there are multiple nice strings, Return the longest substring of S that is nice. If there are multiple, return the earliest occurrence. So since they're saying earliest occurrence, we can definitely do this. We definitely have to do the sliding window pattern because we need to know, we'll need to have like a relative order of when they were added. We'll only do that if we do a linear iteration through or something similar. I was thinking maybe we could throw it into a map and do, if we didn't have to actually return the string, then we could figure this out. No, not without the map, because right, subsequence. So that we couldn't, we need a way to think about it that does not remove the linearity of the characters. A is a nice string. Is A, capital A, comma, lowercase a is the only letter of the alphabet. Capital A, lowercase a, capital A. Lowercase a is a nice string because A/A is the only letter of the alphabet in S, and both capital A and lowercase a appear. Lowercase a and capital A S consists of uppercase and lowercase English letters. S consists of uppercase and lowercase English letters. All right, we know that at least one character will exist. There are no nice substrings. So if we imagine this as sliding window, what case could we have where we want to keep or restart our window size? So what if we use both, right? Usually we use a fixed right side. What if we use dynamic left side and dynamic right side? Go Y, right? A, Z, A, Current version we're using now are pretty much generating all possible strings, right? And if it's nice, we add it to strings, then we return the longest one. If we keep is nice, maybe we could aim for n squared time complexity. I don't know of another way to generate all the strings. Not all possible strings, definitely not all possible strings, but in terms of all strings that start at a particular index and go to the end of the string. With capital Y and lowercase y, maybe we can do something where we filter out all strings. Maybe we could do something where we filter out all okay. There's in this string, right? There's a lowercase z and no capital Z. So what if we filter out, right, all characters, right? We know we get Z's index, right? There's no capital Z. Since there's no capital Z, that's a problem, which means any string that could include Z cannot be a nice string. So we go all the way up to where Z is. There could be a nice string before it. You could have a before, so even if there's a z here, it doesn't actually do anything. So maybe we don't want to remove everything before it. Maybe we'll just remove z. We remove z. What if we do something where we generate all valid ranges of nice strings? So a valid range of a nice string would be, for example, if we look at 0 to 7, right? There's not really a way to 0 to 7, right? The start index here, which would be capital Y, and lowercase index would be lowercase y, actually makes it a nice string. Okay, well, we were onto something with this. Maybe we'll also do something where we see that each, if we know a character, right, is incapable of making something a nice string. For example, we have something like z, right? Z is incapable of making a character a nice string. So any strings that include z's index cannot be a nice string. What can we do with that information? Look at a, capital A, lowercase a. It's like, okay, maybe that could work. So now if we know that anything within this range can't be a okay, wait, maybe we do have something. Everything where z is, right, where z is can't be a nice string. So it splits, right? We either have ya, right, or a, y, right? Now, if that's the case, right, if we look at y is supposed to be able to give us a nice string, but now it's broken the range of z, so we can't use ya, right? But our answer is still in here, so maybe we remove a character from the end. And this would be our longest. Maybe that's what they mean by divide and conquer. Right. Yeah, I wish we knew we should learn merge sort, because I'm pretty sure part of the solution of merge sort is a divide and conquer approach. If we knew that, I think we'd know a way to combine strings as we go downwards. We have y, aza, capital A, lowercase a, y. Maybe we can intuit it, right? Let's say we find all strings, right? Let's say we find all strings or all letters where it's not possible to form they don't have a pair, right? So if we find all indexes where we know that we'd have a map, right? We'd have all indices where we know there's no pair, right? And it could be a set because we just know it's not possible, right? We'd have z, right, in set, which is 0, 1, 2, index 2, right? Then we split the string into 2. I would have ya, like we said earlier, ya and aay. Now we could check if this string is nice. We check if this string is nice. It's not. It's not. I think, what could we do with the information that a singular character is not nice? Or a singular character is incapable of making a range nice. So z is incapable of making a range nice because it doesn't have a buddy. Which means what's left to check is y and a. and A and Y. Yeah, this one would be a recursive approach. I don't really know how to handle. How can we get this to linear time? Given the string S, return the longest substring of S is nice. If there are multiple, return the substring of the earliest occurrence. So I think what if we say, okay, we know that Z, the index 2, right, is incapable of creating a range that's good for us. If that's the case, if we iterate through Y, A, right, Z, we know that a good range for us doesn't include Z. So we'll restart. Then we say A. Okay, we're on to something actually, right? So we have Y. We'll do a pre-iteration, right? Pre-iter find pairless characters, right? If we find these pairless characters, right, one of them will be Z. It will be at 0, 1, 2. It'll be at index 2, right? And the character will be Z. It'll be a set, but we're just trying to make it make sense, right? And now we're going to iterate through the string, right? We're going to iterate through the string, right? And since we're iterating through the string, we're going to say, okay, Y, we'll add it to our string. A, we'll add it to our string. Z, we know that Z cannot be part of a nice string. And we know that Y and A wasn't a nice string either. I think what I know, I think I know what I'm seeing now. So you have pre-iter find, right? Well, pre-iteration find pairless characters. Maybe we also find, no, we can't find characters that, well, yeah, we'd find characters that make us not nice. So we'll say, okay, maybe YA is our longest, nicest string, even though it's not really a nice string. Once we get to Z, we throw it all out, right? Skip Z, and then we go to A, we add it as a nice string. Capital A, we add it as a nice string. Right, then we go to A, still a nice string. Then we go to Y. It's no longer a nice string, so we throw it out. So I'm thinking actually we could do, yeah, what if we actually just look at it a different way? We iterate through the string, right? We'll have a set, right? What we'll say is, as we're iterating through the string, right? We'll say, okay, add car to window. So we add a character to the window, it's Y, right? We also add it to the set, right? When we add it to the set, we'll check, hey, if right, if set has lowercase and uppercase, right, then we'll do, right, then we'll say, right, our longest substring, right, is equal to the longest, right? So it's either, if longest substring, right, dot length is greater than window dot length, right, then we'll give it longest substring. Otherwise, we'll give it window, right? So we're going to be keeping track of two strings. One of them is going to be window, one is going to be longest substring, right? From that point, right, we have Y, add it to the window, we add it to the set. Now, if the set has both lowercase and uppercase, then we want to say it's a new longest substring, right? Otherwise, we don't do anything, right? We add A, right? We add car to the window, add to the set. We don't have a lowercase and an uppercase, so it kind of doesn't matter, right? So it's not a longest substring. We add Z, right? And this is where we know we can throw it out, right? We'll also say, right? If, we'll say else if, we added it to the set, right? Else if set dot has, right? If car exists in pairless characters, right? And we want to reset everything, right? We'll reset our window. We'll reset our window equal to an empty string, right? We'll reset our set to a new set, right? We'll reset our set to a new set, right? And then we'll kind of want to, well, actually, no, if car exists, right? So we'll be at Z, so set equal to window, right? Create a new set. Then we'll go to A, add car to the window, add it to the set. It's not, we don't have a lowercase and uppercase yet, right? Go to the next one, we add AA, capital A to the set, add it to the window. If set has lowercase and uppercase, it does. So we say longest substring is now equal to this new window. We add A, we're still lowercase and uppercase, so it's still good. Then we do Y, right? And it's actually not a nice string, but we'll add it anyway. But it actually stops us from being able to discover other things. Maybe we had another one like this, which would be the actual longest substring. So the other thing we want to do once we reset it, we're going to want to shift, right, all the old, no, not all the old characters. Not all the old characters, because we still want to be able to match to A and A. I think we're almost there with this. Y-A, Z-A, capital A, lowercase a, Y-A, capital A, lowercase a. I think what we want to actually do, you said else if car exists in pairless characters, right? After we break off here, Y is pairless, so it should be added to a pairless character. So what if we do a pre-iteration to find pairless characters? Once we get to Z, right, it exists in a pairless character. We want to reset the window. We'll reset the window. Set will equal a new set. We want to retain some characters from that set. I think I'm seeing something here actually. Can we have these as matching pairs? So we need a lowercase and an uppercase. So I think what if we had a map for every character in the string? And what we'll do is we'll say for all lowercase a's, right? For all lowercase a's, we know all the indexes of them, right? 1, 3, 6, 9, right? So we know a character is pairless. We know a character is pairless if based on the current index we are in the character, right? So in this way, if I move it back to the original example, right, our new map would look something like this. We'd have y equals 0, a, right, would be equal to index 1, right, 0, 1. Let me make this bigger. 0, 1, 0, 0, 1, 2, 3, 4, 5, right? Z is a pairless character. We know it's pairless because there's only one index for Z, and it's index 0, 1, 2. And then we have capital A, which has an index of 0, 1, 2, 3, 4. And then we also have Y, which has an index of 0, 1, 2, 3, 4, 5, 6. Right, now with this new information, I think what we can actually do is we'll know when to break the window. We start at Y, right? We check if it's a pairless character. It's not because we know it has a pair. Right, we go to A, right? Check if it's a pairless character. It's not, so we add it, but it's still not nice, right? Then we go actually we have to change this. If we're iterating through the string, we'll start at Y, right? And we start at Y, right? Iterate through the string, we know that our current window is not the size, it's not nice, right? Because we don't have Y yet, the lowercase y, right? We don't have lowercase y in the set. So we'd have y, capital Y, lowercase a, z. Z is a pairless character because it doesn't have a matching pair in the thing. Since it doesn't have a matching pair, right, it's not possible to actually make a nice string with it, so we should restart. Right, so we have that, right? If it's a pairless character, we want to restart our window. At the same time, if we have y, capital Y, and lowercase a, we have capital Y and lowercase a, z, and then a, we have capital A and lowercase a as well as y. Capital Y, lowercase a, lowercase z, lowercase a, capital A, lowercase a, y. I feel like I'm so close. We have capital Y, lowercase a, right? Capital Y does have a buddy, but we haven't gotten to that point yet. You get to A, right? We don't know if our window is nice, so we need to wait to validate that our window is nice on each iteration, only when there's at least 2 characters within it. That's how we do our set. So if we say Y, right, we add it to the co-window and add it to the set, right? We add it to the window, we add it to the set, right? Now if the set has a lowercase and uppercase, that's not going to work either. And we'd have a pairless character, which means we definitely want to restart. Then we'd have A, okay. Then A, we have both. A, we have both. I think there's one way we could actually do it. Go from Y to A, then from A to Z. Once we find that pairless character, I figured it out. Once we find that pairless character, Z, right, we're gonna actually want to iterate, right? To find that pairless character, we're gonna want to iterate from left, basically from wherever left is, right, for our window. Right, we're going to want to iterate from left, right, and remove indices from the map. Right, so we start from capital Y, right? We start from capital Y. Once we get to Z, because it's pairless, start from capital Y, well, we'd pop 0 off, right? And if it's 0, right, it doesn't exist, so we'll remove it from the map. Then we'll go to this A here, we'll pop off the first A. All right, and then we'll go to Z and pop off that Z. Right, now we'll have A, we'll add it, right? Capital A, we'll add it, right? And then we'll have lowercase a, which is fine. But then we'll have lowercase y, which is not fine because we know that it's pairless. But I think what we could do, right, is instead of doing this part here, right, we'll just do a check, right? We'll say if entire window is nice, we'll have this, and I think this, we're out of time, but I think this iteration, I think if entire window is nice, we'll take linear time in the worst case, and else if character exists in pairless characters. So I think this version of the algorithm is actually n squared, which is an improvement from our original case. So we'll actually try and implement that tomorrow. But hopefully, no spoilers. We want to be able to solve this one. So, what am I gonna say? Dang, I think we're close on this one though. I will make you proud. But yes, day 53. We are back tomorrow.